This is going to take you through problem 7. Most people were close on the first derivative or had it and then messed up the second derivative. So hopefully you can find your error here. V u prime minus u v prime over v squared. So negative 4 x squared minus 16 plus, there's two negatives there, 8x squared all over x squared plus 4 squared. So that's negative, or sorry, 4x squared minus 16 over x squared plus 4 squared. That's your first derivative. Set that equal to 0 or undefined. It's never going to be undefined, but it's going to be 0 when 4x squared minus 16 equals 0. So x squared equals 4. So plus or minus 2, that's your critical numbers. So we have to set our intervals up from negative infinity to negative 2, negative 2 to 2, 2 to infinity, and then plug in values. So we're going to plug in a value such as negative 10. Plug in a negative 10, you get a big positive number for the first term. It's always going to be positive in the denominator, so increasing from negative 2 to 2, you put in 0. 0 minus 16 is negative, so it doesn't matter, it's going to be negative. Plug in a big positive number. So we have a max at negative 2 and a min at 2. Some of you are getting confused as to what to plug in where. So that's your test. You can find the y coordinates for both of those, negative 2 and 2, by plugging them into the original function. And you get negative 2, 1, and 2, negative 1. So that takes care of all the maxes and mins in the first derivative. So y prime equals 4x squared minus 16 over x squared plus 4 squared. That's what we're starting with. Take the second derivative. Get v u prime minus u v prime, chain rule, so 2x squared plus 4 to the first times derivative of the inside, all over x squared plus 4 to the fourth. Now this is the key right here. If you can simplify right here, you can save a little algebra error. You can take an x squared plus 4 out of everything. So that becomes 3, that cancels out, that becomes 1. So you have an 8x times x squared plus 4, and then minus, this is 4x, so 4x times 4x squared is 16x to the third. And then 4x times 16 is negative 64x. All over x squared plus 4 to the third. So we have 8x cubed plus 32x minus 16x cubed plus 64x all over x squared plus 4 cubed. It doesn't help to expand the whole thing. You're going to make your life more complicated. So negative 8x cubed I just made a quick little edit. I forgot to write the x there with that 64. Okay, so we have negative 8x cubed plus 96x all over x squared plus 4 cubed. And that's your second derivative. And now we need to solve for 0, so negative 8x cubed plus 96x is what's going to make this 0. It will never be undefined. So take out a negative 8x and leaves you with x squared minus 12. X equals 0 and x squared minus 12 equals 0. Take the square root. You get plus or minus radical 12, which is 2 radical 3. So these are possible critical numbers. You have to test them. So we go from negative infinity to negative 2 radical 3 as one interval. And then negative 2 radical 3 to 0, 0 to 2 radical 3, and then the one that's sneaking off the page there is 2 radical 3 to infinity. And we're going to plug numbers into our second derivative. So pick a big negative number like negative 10 or negative 100 if you want to go really big. You know the denominator is always going to be positive. So that's going to be a negative and a negative. That's going to be concave down. Sorry. Negative times the negative makes that positive, sorry. So it's going to be a big positive number plus a negative number is going to be concave up. And then from negative 2 radical 3 to 0, I know that in there is negative 1. So if you plug in negative 1, you have positive 8 minus 96, that's concave down. Plug in positive 1, you get negative 8 plus 96 is up. And then plug in something like 10, and you get a big negative number, so it's concave down. So we have inflection at all three of these spots. I think the directions say just list the x-coordinate for the inflection points. Some of you went ahead and found the y-coordinate, that's fine. If you want to, you plug that in the original function. So that is the complete problem. All you have to do now is make a sketch, and you just use your information and your calculator. And if you use your calculator, it looks something like this. And you have your max that you found. There's an inflection point out here, an inflection point at 0. You have your min that you found, and then there's another inflection point. You can't see on the graph that there's an inflection point out there, so you do have to calculate it. The only thing we didn't find were zeros or intercepts, and that's looking at the original function. The x-intercept and the y-intercept are both 0. It's a double catch there.